In the previous video we showed you how you can extract pure piperine from white or black peppercorns. The crude product is a dirty yellow solid which looks like this. It's got a beautiful intense aromatic pepper aroma. What we're going to do today is hydrolyze this piperine. Piperine is an amide, composed of an acid, piperinic acid, and an amine, piperidine. We can use a base to hydrolyze the amide back into these constituent molecules, and our aim is to isolate these two pure products. Here's some more piperine which we recrystallized from hot ethanol. You can see that it forms beautiful long thin yellow needle-like crystals. We're going to use this pure product and the crude product you just saw together in the reaction. Here we go. We're starting off with exactly 7 grams of piperine which we extracted from white peppers. Check out our previous video for details of how we did this. Let's get going. First of all, here's our base. We've weighed out 5 grams of solid potassium hydroxide flakes. You can probably use sodium hydroxide as well for this reaction, but be warned that you might need to use a bit more solvent and reflux for longer, as sodium hydroxide isn't as soluble in ethanol as potassium hydroxide. Keep this covered up so it doesn't absorb moisture. We're going to use a 100 ml flask for the reaction, equipped with a magnetic stirrer. We're using the flat-bottomed flask just simply because it will enable a better heat transfer from the hot plate. Now for our solvent. Here's 40 ml of absolute ethanol. You can probably get away with azeotropic ethanol as well, just provided that the piperine dissolves okay in it and doesn't start to precipitate out. Let's first get this in the flask. And now we'll add the potassium hydroxide flakes. Get this stirring vigorously and it will take a few minutes for the potassium hydroxide to dissolve. It will produce a little bit of heat in the process. Here we go. All in solution. Now we need to add the piperine to this. With a bit of stirring, this goes into solution as well. So keep adding the piperine and get it all in. Here we are with all the piperine added. Some won't dissolve immediately, but don't worry about that. Okay, now we're going to set up to reflux the mixture. It's a simple setup and we're using a condenser that we can later rearrange and use for distillation. As the mixture heats up, the remaining piperine dissolves, forming a dark solution. If you use totally pure recrystallized piperine, then you'd probably have a more orange or yellow colored mixture. Get the heat up and the mixture refluxing well. We're going to hold this at reflux for the next 3 hours. What's happening in here is that the hydroxyl anion from our potassium hydroxide is acting as a nucleophile and attacking the double bond of the amide, forming an intermediate. The intermediate, however, is unstable and then reforms the oxygen double bond, but with the piperidine part of the original molecule splitting off. What's left is a carboxylic acid, but in the presence of the potassium hydroxide and piperidine as bases is quickly deprotonated and effectively forms the carboxylate anion, which teams up with the potassium ion forming the potassium salt. And about an hour into the reflux, you can see that the color has changed slightly. We've got the fine precipitate of the potassium salt of piperinic acid forming. Keep the reflux going until 3 hours is complete. Okay, here we go. You can see there's quite a lot of yellow-colored precipitate in there now. Allow the flask to cool a little bit, but not completely. And now we rearrange the setup for simple distillation. We're now going to distill off the ethanol from the reaction mixture, and as we do so we'll also bring off the quite volatile piperidine reaction product as well. Take your time with the distillation. You don't want to use too much heat that the potassium piperidinate salt in the boiling flask gets burned, but you also want to evaporate the mixture down to complete dryness. We used some aluminium foil to insulate the still head so that distillation was more efficient. We find that the excess alcohol comes off, mixed with a little bit of the piperidine. But it's the fraction coming off close to the end of the distillation which contains the bulk of the product, as the boiling point of piperidine is 106 degrees C. Half an hour in and the mixture is starting to become a paste. Keep going carefully with the distillation, as we now need to get the remainder of the piperidine out. And this takes some time. To speed things up a bit, you can also attach a vacuum pump. We continued for another hour to extract as much of the product as possible from the boiling flask. And here's our two products. On the left here we've got a solution of piperidine in ethanol. And here's our boiling flask containing a semi-solid paste of potassium piperinate, plus some residual piperidine. We'll come back to the ethanol and piperidine solution later on. First we'll work up the potassium piperinate salt. Unlike our starting piperine, the potassium piperinate salt is soluble in water, so here's 50 ml of water. You'll need to stir well for about 10 minutes in order to break up all the lumps and get everything to dissolve. There's a pretty funky, spunky, unpleasant piperidine aroma to the mixture as well. But you'll notice that most of the original spicy pepper aroma has dissipated. Okay, here we go. There's a small amount of unreacted piperine remaining in there, so we'll need to filter this before we do anything. Wash the solid that remains with a little hot water to make sure we've got all our product out. Okay, here's our dark-colored filtrate containing the potassium salt of piperinic acid. The free acid is insoluble in water, so converting back to the free acid is easy. We simply add concentrated hydrochloric acid dropwise to the solution until we've got it all out. So here's about 15 ml of acid, which should be more than enough. You can see the yellow-colored piperinic acid precipitating out as the acid is added. Soon the entire mixture becomes a mass of yellow precipitate, and the conversion is complete. So time to filter our first product. Wash with cold water and then dry. Break up the lumps to get it as dry as you can in the filter. Here we go. This is still quite wet, and so it takes a few hours in the oven at 100 degrees C to get it completely dry. And after drying, here's our piperinic acid. 4.6 grams in total, which is an 86% yield on our starting piperine. It's got a really interesting aroma. Not spicy like pepper, but slightly sweet and a bit like pungent bubble gum. Now for our solution of piperidine in ethanol. Piperidine is a secondary amine and a strong base. To isolate it, we're going to convert it into its hydrochloride salt. So we're going to use this setup here. There's a flask on the left for hydrogen chloride gas generation, leading to our flask containing the piperidine solution. Here's some sodium chloride we placed in the flask, and here's some concentrated sulfuric acid. When these are mixed, we'll get hydrogen chloride gas generated. Okay, let's go. A dense mist is first formed in the flask as the hydrogen chloride passes through. No need to do this quickly, just slow and steady is good. Let's check the pH after about 5 minutes. Just very slightly acidic. So we'll keep going a little bit. And now try again. Strongly acidic. So all our piperidine is definitely converted. So we're done with gassing the mixture. So now we're going to evaporate off the ethanol solvent, hopefully leaving behind our piperidine hydrochloride salt. We've set up for distillation. And although you don't need to, we're going to use a vacuum just to speed things up. As the ethanol evaporates, a white solid is left on the side of the boiling flask. And here we go. About 45 minutes later, everything evaporated off, leaving our product. Here it is. 1.3 grams of off-white crystalline dry piperidine hydrochloride. This is only a 44% yield from the theoretical amount, which is pretty typical of the recovery that we get. If you want more, you could try evaporating the reaction mixture even more, or perhaps adding some more ethanol and distilling again after the first go. If you've got the better quality vacuum pump for this, then it will help. We have also tried extracting the piperidine from the reaction mixture directly using DCM, but it forms the nasty emulsion. Using a different non-chlorinated solvent might be another way to do this though. And here's our final two products. Piperinic acid and piperidine hydrochloride. Together with 100 grams of the top quality Cambodian compote peppercorns that we used for the original piperine extraction, and from which the product originate. This is probably not a large-scale process, but a very satisfying bit of work which is a good test of your lab skills. Thanks for watching and stay tuned to see what we've got planned for our products.